The theory of carrying capacity states that in a snapshot, the factors of an environment determine a species' maximum potential population, as well as the population that the species will approach over time. This can be applied with humans across the entire planet, but it must take into account our abilities and technologies to transform our planet. In the beginning, humans were restrained by the carrying capacity of the world. As hunters and gatherers, humans were bound by the amount of energy that they could create for themselves, putting us on the same level as all other animals. We were a part of an energy system that was only able to provide for us what we received from the sun, which reacted as a steady state. Our population on the planet hovered around 10 million during this time. Then we began to invent technologies. This started with simple tasks such as farming around 10,000 years ago. This gave us access to a much larger energy resource pool. Dubbed the Neolithic Revolution, our population steadily increased from this point to where we were farming efficiently. And some say we never hit our max carrying capacity, as just farming projects us to reach approximately 1 billion. Then the next great source of energy was found. With the discovery of oil and the Industrial Revolution in the 1700s, humans had unlocked stored energy in the earth. The energy systems we previously relied on were overtaken by this new form of energy. Harnessing this energy gave rise to the population of the world we know today. As energy was in a surplus, we no longer were restrained in our carrying capacity. With an exponential rise in the energy available to humans, it seems as if the population is only going to continue to increase. It looks almost certain that our civilization is on a path destined for consuming all possible resources on the planet and causing starvation amongst all humans. This was predicted by Thomas Malthus in the 1800s, but this might not be the case. As more and more data becomes available, the UN is actually predicting the rate of the world population is decreasing, and we will never reach 12 billion. Of course, these estimates are up for debate and scrutinized, so the UN has included upper and lower bounds of 16 billion and 4 billion as the carrying capacity of the world in its current state. Is this carrying capacity of 12 billion sustainable on our planet? There are a bunch of questions that must be answered before we can fully know that answer. Considering our current energy flow largely depends on non-renewable resources, humans will be hard-pressed for another solution to sustain our energy consumption. We can assume that by the time the population is leveled off around 12 billion, everyone is living in a first world state. By averaging first world energy consumption per capita, we find that at current energy use, our global demand per year would be approximately 5,500 kilograms of oil per person. That means that to keep the carrying capacity level, our world must find a way to produce 66 gigatons of oil per year. There are some ways that are being theorized to accomplish this without only relying on fossil fuels. Current renewable technologies are not able to sustain the energy demand of our world, mostly because they are irregular power sources. A way this can be overturned is by increasing energy storage and these renewable energy sources such as solar, wind, and tidal. If storage is big enough and we are creating surpluses of energy during certain times of the day, we will be able to distribute these power sources across the entirety of the day. The next option is to reinvent a renewable power source that outputs enough energy constantly to sustain the human population. Many theorize that fusion nuclear is the next step. Unlike fission, where heavy atomic particles are split and release energy, and a product is radioactive material, fusion uses water and lithium to create deuterium and tritium plasma. Abundantly available, these sources are able to power these reactors, which only release helium as a product. The cost of electricity of fusion technology is already projected to surpass most technologies. And as with any technology, the longer you work with it, the costs only decrease as you learn more and more. As can be seen, the energy density and cost per megawatt is a strong advantage for fusion technology. We might not be doomed for a crash in population due to our dependence on energy to keep our carrying capacity high, as there are many solutions to this problem. But this is not to say we have guaranteed our survival. There are countless other problems that may impact our lives, be it the warming of our globe or the chance an interstellar object hits the planet. All we can do is tackle each problem one at a time as humans do their best to survive in a rapidly changing world.